Hi, my name is MD Fayaz Alam and welcome to my YouTube channel. Here in this video, we will discuss about credit risk modeling. So first, we'll discuss about the business problem. You see, in current times, we see that there have been large amount of loan applications that go to the banks. Okay, there are different banks and NBFCs, and it has become very much easy for people to just go to the bank or visit the website of the banks and then check. Uh, Means they can simply input their details, personal details, and based upon those details, the bank gives the confirmation that whether they are eligible for loan or not. So in this project, we are going to develop that application. Now, what is the benefit of this application? See, banks receive large number of applications on a daily basis, and therefore it is not feasible for them to check the eligibility of each one of the applicants individually. That will become very much hectic and it will slow down the process. So to tackle this, what they do, they use machine learning algorithms that are being trained on previous data consisting of loan and whenever the input features are given to the model, it gives an output stating whether the the loan will get default or not. If the loan will get default, then the bank will inform the applicant that they are not eligible for the loan and therefore the process cannot be moved further. However, uh, the if the model gives a response that yes, the applicant is eligible, then the process moves forward. The details of the applicant is then reviewed by a personal manager of the bank, and then the further process takes place. So this helps the bank to filter out all the possible uh, applicants who have high probability of getting defaults in their loan. So this is what the application or benefit of this uh, application can be. So you can see first in the first cell we have imported all the libraries that we are going to use. Okay, such as pandas, matplotlib, seaborn, numpy, sklearn, stats model. So these are the different libraries that we have used. And in in the preparation of this modeling, we have used three different data sets. The first is customers data set. It contains data related to customers, such as customer ID, age, their gender, marital status, income, the number of years they are staying at current address, the city, state, zip code. Then the other data set is loans.csv, where data related to loan given to the applicants are present, such as loan ID, customer ID, what is the purpose of the loan type, sanction amount, the loan amount that has been given, the processing fees, GST, and others. And the third data set that we have used is bureau data.csv, which contains data uh, related to the loans that they have taken. For example, the total number of open accounts, the number of bank accounts that the applicant is having, then the number of closed accounts, the total number of months means till now, what is the total number of months that the applicant has been under loan. Okay, then delinquent months. Now this is important. Delinquent means uh, the number of months means the months where uh, the applicant has missed the loan date. Means, for example, let us take an example that an applicant is has taken a loan of 1 lakh rupees, and his EMI, he needs to give EMI on every second of the month. So, for example, the loan starts from 2nd January. So on 2nd January, he needs to pay his first EMI. Then on 2nd February, the second EMI will get started. Then on 3rd, uh, um, 2nd of March, the third EMI will be given. So in this way, the EMI dates will be distributed. Now, uh, the first month means June to uh, the applicant has given the paid the EMI. Now, in second month means on 2nd February, the applicant was not able to pay. He was able to pay on let's say 3rd of February. So by one day he has missed. So the total delinquent day will be one. Okay. Or delinquent month will be one. Means in 1 month out of means for example in in this example uh, we have considered 10 months, and out of these 10 months only one time the applicant has missed the payment date, and therefore the total delinquent month will be one. So that is what delinquency means. Okay. Then total DPD. Total DPD means total number of days. By total number of days, the applicant has missed. For example, as we have taken the first example means uh, in second month he missed the payment by one day. So one day. Then, for example, on fifth month, he missed the payment by 5 days. So 5 plus 1, 6 days. So total DPT will be 6 days. So that is how total DPT is calculated. Number of inquiry count means how many times the inquiry has been given by the applicant to check his or her loan application. And then this is credit utilization ratio. This means the total amount means eligible amount for a user, and the total divided by the total amount that he has used. Okay, so that is what ratio is. Means how much amount he has used as compared to the total sanction amount that can be given to him. Okay, that is what credit utilization ratio is. Next, what we have done, we have simply merged all these three data sets into a single data set, which is called final complete data, uh, with the help of customer ID. Okay, by using the merge function of pandas. Okay, so this is the complete function data. It has 50,000 records and 33 columns. Next, we are checking the number of missing values, and we see that none of the columns are having missing values except this residence type, which is having 62. So, what we are going to do, since this is a categorical variable, we are going to fill this with mode value. So, mode means the highest number of category that is happening. So, after checking this, after filling this missing values, we are again checking to ensure that whether we have handled the null values or not correctly. So now we can clearly see that none of the columns are having missing values. So we move to the next part, which is to check the number of total duplicates that are present in the data set, and we can clearly see that there are total zero duplicates. So this is a very good sign. Next, we want to drop some of the ID columns, means custom ID and loan ID, as they are not going to help us in developing our machine learning model. So we are simply dropping it. And zip code also, in zip code we saw that the zip code is having an object, n- numerical character. Since zip code is treated as an object, so we are converting it into string. Next, what we are going to do is we are checking the distribution of the categorical columns. Okay, so these are the categorical columns, and these are the distribution. So for example, gender we can say that around 30,000 records are belonging to male, whereas 20,000 records are belonging to female. Then marital status, so 27,000 records are associated with man or female, whereas 22,000 records are associated with single men or female, men or women. Okay. Then employment status is there, residence type is there, Distribution of city is there, distribution of state is there, zip code, not very important. Loan purpose important. So we see that the highest category is personal. Personal loan is the highest category. We can also see that there are some uh, improper or incorrect entries as well. So personal and personal, these should be kept together. So we'll do that in later part. Then education loan is there, home loan is there. Then distribution of loan types. So there are two types of loans, secured and unsecured. So 32,000 records are belong to secured, whereas 17,000 are belong to unsecured. Okay. Next, what we do, we are again checking the distribution of the numerical columns. Previously, we checked the distribution of categorical columns. Now we want to uh, check the distribution of the numerical columns. So we can say that the age is fairly normally distributed. Then the income, we can say clearly see that there are outliers here, and which is actually expected. So there will be some of the applicants which who will be having a very high income, okay, as compared to most of the applicants. So and then distribution of loan amount is also shown here, which gives us the idea that okay, yeah, it is also having some outliers, which is also again expected. So next, what we want to check the statistical information of the data set so that we can have an idea about how this data set is going through. Okay, so we can see that age the mean is 40, almost 40 years. The max value is 70 years, and whereas the minimum value is 18 years. Okay, so which is okay from 18 years only. The uh, people, we are considering that after 18 years only, people uh, will become eligible to apply for loan. Okay. Next, for example, let us see GST amount. Okay. So GST amount, we see there are certain problems here. Okay. So minimum value is zero. Okay. And then maximum value becomes this much. Now, generally, the GST amount for loan is only around maybe around 2 to 5%, or uh, at most maybe 18%. But here the amounts are means 8 lakhs. So that is way too high. Then again, processing fee also, this the means you can means understand by considering the gap. See, the 75 percentile is 92,000, and then the maximum value becomes 5 lakh. So this is very off. Here also means 82,000 is the 75%, and then the maximum value becomes 8 lakh. So means it suddenly got very high. So this is problematic. So what we are going to do here, we are checking that uh, whether give us all the records where the processing fees is less than the amount into 4, means processing fees should not be greater than 40% of the loan amount. And here we saw that around 15 records were there where the processing fees was too much high, so we have discarded those uh, records. Okay. And we are also checking whether principal outstanding is less than zero or not. So none of the records are there. So we just keep it. Then, uh, then one also sanity check is important, that whether the loan amount is greater than the sanction amount. So here also we can say there are zero records. So that is a good thing. Okay. Next, this is default is our categorical variable where it is present in the form of true and false. So uh, we do not want it to be like that. So we just convert it into integer 0 and 1. Okay. Then we just perform certain basic exploratory data analysis. So these are the results. Okay. Next thing that we have performed is the using the VIF method so that we can uh, consider the most important numerical variables that are present in our data set. So after performing this, this is the result that we got, and we can clearly see that there are certain variables that are having too high VIF values. So we will not consider those. So we are just for confirmation, we are also checking the correlation, and we can clearly see that these variables are having too much correlation. So this can introduce the problem of multi-collinearity in our uh, model. So we want to avoid it, and therefore we are just dropping those columns. And these are the columns that we are dropping so that we can avoid the problem. And then we are again checking the VIF, and here now we can clearly see that the VIF value for all the variables are now less than 10. So 10 is the threshold that we are considering. The VIF value for the variables which were having greater than 10 VIF values, we have just removed them. And this was removed one by one. It is very much important for us to consider that VIF value based on, we cannot simply discard all the variables altogether by checking the VIF values. It should be done in a sequential manner, okay, one by one. Then we have calculated the information value to consider the most important categorical features that are present in a data set. So this is the result that we have obtained, and then based on this, we can see these are the features that we have considered, and these are the selected features. Okay, okay. So these are the selected features, and now we are since we are having some of the categorical variables and it contain name objects, so we have to convert them into numbers. So what we are doing, we are using the one hot encoding with the help of get dummies. So for these three variables which are categorical in nature, we are replacing them with one hot encoded variables. Okay. Next, we have selected the x and y. X is the input variable and y is the target variable. Then we have performed the min max scalar so that we can every variable falls on the same scale. And then we have separated the data set into training and testing set. The 80% of the data set is used for training, whereas 20% is used for testing purpose. Okay. So the first model that we have created means model training with default parameters is logistic regression model, and this is the result that we have obtained. We can see that 86.7% is the accuracy. Now, one very much means one is in banks. See, it is very much important in banks to identify all those applicants who have high probability of getting defaults. It is very much important. If, for example, in doing this, for example, if they consider an applicant who means who by mistake the model gives that okay, this person will not get default. So further analysis can be done by the underwriter. But uh, if the model says okay, no, means model is perfectly means fully confident about the applicant that he will not get default, and later on he gets default, so then that will be a big problem. So recall becomes very much important, means reducing false negatives becomes very much important here, and that is the reason why we are giving more focus on recall. So we have to be targeted a recall to be above 90%. Okay. So here with default parameters we have obtained a recall of 90%, and we can clearly see that the data set is imbalanced, which is a normal thing. uh, then we have trained another model which is called XGBoost classifier. And here we can see that the recall is 86%, so it is less than the logistic regression model. However, the overall accuracy is 95%, but we will not see the accuracy as it can be misleading here since the data set is imbalanced. So the next model that we have created is LGBM classifier. So here we can clearly see that it has obtained a very good recall of 94%, and the accuracy is also very good. So in comparison of all these three, we can clearly say that LGBM was uh, has given us the best result. Now the still now we have developed these models with default parameters, but now we want to optimize the parameters, and we are going to perform this optimization with the help of uh, Optuna. Okay, Optuna is a library which helps us to identify uh, key hyperparameter values in an optimized way. So for logistic regression model, we have done this, and this is the result. Best trial score is 64%. Then XGBoost model, we have also done this, and and this is the result of XGBoost. So 96%, 86% recall, not very means high as compared to the default one. And then LGBN. Okay, so LGBM, now we can say that 95%. So 1% means 0.1% increase in the recall value, 0.01, sorry. Okay, so this is the complete. And if we compare all these three models, we can clearly see that light GBM model is the best performing model, as it is giving us the best recall. Okay, next we also want to identify the most important features that are present in our data set, and for doing that we have created a sharp plot. So from this plot we can see that credit utilization ratio is the most important feature that we are having, which is followed by total DPD, loan purpose, home loan is the most important, and then so on. So these are the most important features that we are having. So after doing this, we have also performed the fairness analysis of our model so that we can understand whether our model is fairly treating the applicants or not based on age. Okay, so what we have done, we have divided the data set into age bins, which are 0 to 25, 25 to 40, means under 25, 25 to 40, 41 to 60, and above 60. This is the range in which we have added the age. And then we are going to analyze the selection rate, true positive rate, and false positive rates. Okay, so this is the result we have obtained. So selection rate, in terms of selection rate, we see that the model is has selected around 16% of the applicants as eligible for loan between 45 to 25 to 40. Then between 41 to 60, the loan applicants is means 12%, and above it becomes 8%. So we can clearly see that the model is saying that as age is increasing, the selection rate becomes the selection rate decreases. Okay, then the true positive rate, in terms of true positive rate, means whether the model is giving equal opportunity for to all the age groups or not. So we can clearly see that it is around 0.95 to 1, so means almost same is there. So uh, it is maintaining a good equal opportunity, and it is giving almost equal opportunities, means equally treating all the age groups. Then in terms of FPR, means false positive rate, as well we can see that the range is between 0.041 to 0.079, and it is also relatively low. So this also uh, tells us that the model is reasonably balanced under equal opportunity and equalized odds criteria. So this is the complete work that we have done, and you can take use this code for your project as well. I have attached the GitHub link in the description from where you can check the code and use for yourself. Thank you.